26, we have to draw these curves and then find the area between them. So we will begin by drawing the absolute value of x. Now it's a fairly straightforward curve where it is just the identity function on the right hand side, and on the left hand side it is just the same, but we reflect it over the y-axis. So it goes like so. So this is y is equal to absolute value of x, and now we need to draw the second curve, x squared minus 2. Now, x squared minus 2 is just a parabola that opens upwards, but it has been shifted downwards by 2. So the vertex is at minus 2. So it should begin here, and yeah, it should begin here. And the roots will be at square root of 2, so somewhere around here. It will do this. And as we can see, the area between them is all this section over here. Now we do have this nice symmetry where we can simply integrate the left-hand side, like from 0 to wherever they intersect, because the areas of the left-hand side and the right-hand side, they are the same. And they are the same because the absolute value function and the quadratic function do have an axis of symmetry. So we do need to find where they intersect, right? Over here, let's find this point. So we're going to set these curves equal to each other. So that is x squared minus 2 is equal to, well, on the right-hand side, we do have the positive part of the absolute value function, so that is just equal to x, right? If we were considering the other side, we would have x squared minus 2 is equal to minus x, because the slope on the left-hand side is minus. But right now, we're only considering the right-hand side. So let's bring everything over to the left, and then we'll factor it. So x squared minus x minus 2 is equal to 0. Therefore, this is x minus 2 times x plus 1 is equal to 0. And so x is equal to 2, or x is equal to minus 1. Now, minus 1 is not a solution because as the graph does not behave the same after on the negative side of x. It's no longer y equals x, but rather y equals negative x. So the only solution that we care about is x is equal to 2. This is described by this point over here. So now that we find our point of intersection, we are just going to set up this integral, and we're going to say that this is twice the integral from 0 to 2 of the upper function, which is just x, minus the lower function, which is x squared minus 2. So minus x squared, and then minus 2, which is plus 2, all of this times dx. And I hope it is clear to you guys why I'm taking twice the integral from 0 to 2 instead of breaking it down into two integrals, which I would have to do because these equations change, right? So the absolute value of x is equal to just x if x is greater than 0, or negative x if x is less than 0. So we would have to break it up into two different integrals because the upper boundaries are different. So we're going to just take advantage of the symmetry and then make twice the area from 0 to 2. So once we have this, we are just going to apply the reverse power rule. So this is 2 times x squared over 2 minus x cubed over 3 plus 2x. All of this evaluated from 0 to 2. So now we just plug the upper and lower boundary so that it's 2 times 2 squared, that is 4 over 2, minus 2 to the power of 3 is 8 over 3 plus 4. And then the lower boundaries is just 0, right? So that would just be minus 0 plus 0 minus 0. So when we work out this math, this becomes here 2 times, that is 2 plus 4, so 6. 6 minus 8 over 3, which turns into, let's see, 6 minus 8 thirds, and then all of this times 2. That should be 20 over 3. So 20 over 3 is it is the area, right, between these two curves. And we found it by just drawing out and then realizing that they are symmetric. The area is symmetric, so I just went twice the area from 0 to 2. And I found that too by setting the equations equal to each other and then finding the point of intersection.